Well, thank you for everyone for attending. Taking an hour out of your day. I see some here are here pretty early. Some it's getting a little later part of your day, but it's not often we get out of the house. Well, figuratively, but it's been a while since I did one of these presentations, and I'm glad to be here. I'm on a passionate topic: earthwork and meshes. So I'll promise not to get too far ahead of myself and get too excited during the presentation, but I'll make a promise. All right. So, with that, I'm going to put a challenge out there. We're all about this model, the 3D model. BIM, we have all this other stuff going on. But I'm going to challenge your methodology, your software that you're using, your workflows, your concepts. Does the software know what's in the 3D model? Does it know the difference between existing, proposed, unsuitable, hazardous materials? Does it know about basically the construction sequence? Can you limit things by the sheet? Does it scale well? Do you have to be an expert at design software, especially modeling and grading, to do earthwork, quantities, and stuff of that nature? And really, should you have to be? Well, just think about that. So in this file, we just have a plain old intersection. A lot of us seen this all the time, but I came into this project late in the game. I did not design it. I believe I could give credit to Scott. If I missed anybody, there's several others that helped. But we have an interchange here. I have several dozen DGNs. They're referenced in. I don't know too much about it. So basically at this point, I could just go in here and run cut fill. The software knows what you made. It analyzes the three-dimensional model, looks at that mesh, and determines what is it. Is it unsuitable? Is it design? Is it existing? You put all that effort in your standards in your model. Software should know about this stuff. It should be almost automatic. You did all the hard work with modeling. So with that, it was able to establish the cut, the fill represented between your design and existing. How do I get a report out of it? Do I need to be an expert going to the template library, know target aliasing, clipping, and all that? Wouldn't it be nice to be able to look at the 3D model and yank everything out of there and start looking at the volumes, the slope areas, the cut, fill, right from that model? Now, that's the beauty of this process. It's after that design. You don't need to know about the design sequence. You don't have to know about the templates or anything else like that. You don't need to put the complexity within your model to get that stuff working. Really, that's the whole process. Now, this slide I stalled from about 2006, but it's the KISS principle. Keep it simple, easy. You put all that effort there. That is the goal of this process. I mean, we started working on this concept that you're seeing today almost, I would say, a decade and a half. So it's growing. People are taking it up, and there's a lot of reasons for it. So we're trying to take a step back as we go forward here. Right now, the models we're seeing from you folks has been incredible. From conceptual design, as you can see with the animation there, to cut and cover tunnels, even the curvature of a little bicycle culvert being modeled, and even stuff like this earth dam over here showing sandbags being subtracted from the actual embankment. People want to know that level of detail. It's getting really, really interesting with that amount of detail, and it's obviously just not used for visualization. Now you add this in, and obviously, fly eagles fly here, but if you're going to Philadelphia and you look at this little data clip here, reality is starting to become much better. Between reality model, better ways to capture survey existing information, the models are getting richer and richer because you have better data going in, meaning better data going out, and that's the bottom line. Well, you got these other driving forces. You got the IFC. These models are getting driven also by those deliverables. Also, BIM, the level of detail in those BIM models, level 0 going all the way up to level 3. It's starting to drive the process. The design needs to be much better. Well, the same case, here's an example from Parsons. You start looking at some of these models, it's a lot of lanes. There's a lot of detail going here. There's a lot more going on than just a simple road or driveway. These are quite complex models. take a step back. I stole this slide for something I did several years back, but really, we got to do better than this. This was the driving force of working with mesh, working with Earthwork derived from the three-dimensional model. That is the whole premise here. Yes, this is what we had to do because this was the tools available. We have 64-bit machines. We have larger access to memory. There's things moving to the cloud. We could do so much more. So really, all the stuff is summary of exactly what we did going forward with Earthwork. Coming into this ORD realm, it really opened the doors, and it's something that we've been planning for as we all moved from our SS3 to SS4. You start seeing the cut fill tools coming into play, but when you got to ORD, things changed. Well, now these are the reasons why they changed and what we're after, where we see the direction, and just because of the complexity of the models and the level of detail, it's actually incredible. So let's take even another step back. Take a decent sized project. This is a mega project, but there's a small sample here, and I'm just in here on screen capture, and basically I'm doing some cost analysis. Simply modifying a profile, just a little parabola, shouldn't be that much, but you got to remember there's stockpiles, there's roadways, there's rail, there's multi-disciplines being all tied together here. A simple little change on parabola. Now, I could go do it and then try to figure out how much of a difference in cost it actually is with these large mega projects, but wouldn't it be nice to be able to go back to the model, rerun the cut fill as we showed before, and see the fact that just with that simple change, there's a 40,000 cubic meter change of cut. Maybe it's helped me with my mass order and with my earthwork. I'm gonna have to move that dirt in a more efficient way. Has anybody seen the price of fuel for the machinery that has to move this dirt? Well, these factors are all a part of the game that we have to play, and be able to get that information and not being the expert of doing the actual modeling and design is critical here. So other people with other expertise get involved, use tools to access this model and make those decisions on driving that design and serving the owner operator their best interest. So the question comes back. We hear it all the time. Why mesh? People say, well, there's solids out there. Well, we looked at mesh, and mesh is very performant. A simple task of just going down a road, doing end conditions, and draping on existing ground to find the solutions is a process. Well, you guys, when you could do 10 miles, you'll try 20, and if lo and behold somebody has 100, we have people then with a couple hundred, then even 1,000-kilometer corridors. Well, there's a lot of drapes going on with that. You start thinking about that, you add, if it was solids and you're draping on toruses, helixes, and stuff like that, lofted surfaces, and the formulas with that, it's not as efficient. Scalability is key. We're not going to start throwing any smaller design at what we do. Breaking models up and stuff, it's no fun. If there's a reason to break it up, either with the Federation of Division of Labor or staging and sequencing, hey, I prefer to do that. I don't want the software to dictate when I have to start breaking up files. So we try to keep it as scalable and performant as possible. Speaking of scalability, we limit the range. When we do these cut fill analysis, we have a large existing surface. We have designed just a small section. We're able to clip and take apart the existing ground and with the limits of the design. Then we're able to break it apart. We can multi-thread it, give you that process where you're using all those cores on your computer to get the job done. Instead of sitting there for 10 minutes, hey, knock it down to 2. Oh, a minute, 30 seconds. Over time, we've been seeing, that's what we've been doing with this technology. That example we had with 40,000 cubic meters, excuse me. Obviously, that makes it a lot easier. If it's quicker, and more performant, you'll check your design more frequently. Flexibility is another key. The one thing we like about mesh, isn't it similar to the train? Just keep that in mind as we go forward in this presentation today. Other things about mesh that you gotta like, well, we have other properties. You might have noticed some of these. The top slope area, basically anything that water hits, is the area that we're usually interested in. You start thinking about seating on a 3-to-1 slope. Is that really a planar area? Would that work? No, we like the slope area. A retaining wall, we'll show that in a little bit here. What about planar area? We could just get the 2D area of that. Might work for a tack coat because really, 2% road, 5 to 8%. Really, what's the difference? But you could. It's your choice. If you're used to using 2D area, you could get that. But that information is on there. So let's take a look. We have a simple retaining wall. And over here in dynamic section, you can see that we're looking at just a simple MSE wall. I'm really interested in getting the slope area of the front face of that wall. Maybe that's how I cost it out by the area. Maybe it's the paint on that. Maybe it's the foam liner for the concrete work. So how do I get that? So I could go in my template, and I'm just going to show you how to do this. I'm going to basically I'm going to show that I have an extra component on here, wall area for the MSE wall, and I just basically draped it on top of the existing points that I had. That's fine, but there's a key to this. We keep a slope of, make sure we get it, 10,000%. This actually looks at things that are not shear vertical, because obviously you look at the parallelograms representing the pavement, we don't want to show those also. So with that being 10,000 foot, when we run a report for quantities, we're going to just run it for the entire model here. We'll get that feature definition. Feature definition is obviously wall slope area MSE. We see it's roughly about 5,700 square feet. So okay, that's good. That's what I'm after. It's a great way I could get in the model. If I wanted a right wall, left wall, I could make two different feature definitions. I could break it up any way I like. I also could start breaking it up by name boundaries. We've seen a couple of presentations today with that, but in this case, I'm shutting all my other mesh off, and I'm just putting that on, just to see that slope area for that wall. So basically clean up my report. That means I could split up not just the volumes, as you probably already know. What about the areas? What about the linear lengths? What about the points within these name boundaries when I was doing these quantities and this earthwork? All this costing, basically. But you can see in here, 2,900, 2,800. Oh, that's very darn close to 5,700 if I just did the entire model. I mean, we're talking decimals of difference between the two areas just with us clipping that MSE wall mesh into two pieces. So we're talking about costing. Well, little segue here. We have Mr. Dan Ahern helping on the calls. He's doing a presentation tomorrow on item types. Take it to the next level. The single source of truth with the mesh and item types all goes hand in hand. So if you want to learn more, this is the next step. You can start seeing how the argument all comes together here. So continuing, why mesh? Well, it's very similar to the terrain. But mesh could be a little bit better. It could be closed. You start thinking about substrata surface, 3D geotechnical models. Knowing what the top and the bottom is somewhat important. Having closed for volumes for pavement, it's pretty obvious why it's important. But it also could handle vertical and overhangs. Makes you start thinking a little bit here, what could possibly be done. The key is, it needs to be civilized. Software needs to know what it is. And that is the key, and we'll talk about that as we proceed. So this is a very good slide. And basically, it's our volume options. So obviously, the design, pretty explanatory. Our existing ground, our existing mesh, just going to point that out. None, just ignore it. I just don't want to contribute. Maybe it's a Jersey barrier. I just don't want it to be included within the earthwork. It's already been contributed. I don't want it to be there. Maybe a structure or some kind of item I designed with the Open Roads tools, not OPM or whatnot. Subgrade, people ask a lot. Think of the old inroads days. You have a DTM with a subgrade. It's design. It's just there for porting stuff forward. But think of it as design. Substrata, obviously our geotechnical surfaces, and then we have the cut fill here, which is our meshes that we produce looking at the model as we showed. Unsuitable, existing pavement, muck removal, hazardous material, topsoil, and then custom. When you're looking at maybe backfilling MSE walls, you have to take out some existing ground. You're gonna have to obviously put some 2A modify back in, you have your design. It's just a very special case. So it's just another item out there, another tool in your toolbox. Obviously, I'm highlighting a few things. Certain things only could be mesh, cut, fill, and suitable custom, substrata. Obviously, we need things that are closed. For a geotechnical surface for rock, yeah, you have a terrain model, it's top. Now, when you start looking at this analysis, how do you know what's top and bottom in these models, especially when these terrain models terminate and are voids within the geotechnical model? Very difficult to just distinguish for the software what to do. This case, that's why we require mesh. It's where the future is going. You could do so much more with it, and with that technology growing, that's why we have it as for mesh only. Remember, existing mesh also could be used. Little segue there. So let's talk about modeling the existing. A lot of folks I know, we do earthwork much differently. You look across the country in the United States, it's very different. You go across the world, there's even more variation. It's amazing how many ways we could basically do the same thing, but it's basically how we drive our cost. And it's a cost driver for our design. Removing existing pavement, it just doesn't happen for free. Basically, it's a part of the whole cost analysis that we do. So really, you could use the tools that you do your design with our existing design tools for our existing mesh. Excuse me there. Also, it could come from other places, along it's civilized, and we'll talk about that more as we proceed. So we're looking at the new release that's pending almost any second now, coming out shortly. And we have we referenced in some existing survey chains. We took the liberty here to make some voids within the infield, closed shapes, excuse me. And let me just get this going. But we can see that these infields are great places where topsoil is king in some places. It's a high cost. In this case, I want to pick this stuff up, and since I know it's between the existing pavement, I know that's topsoil in this area. I want to take a foot off, and now we have the ability to take selection sets. You just don't have to do one, then the next, then the next, then the next. I could have 50 of these shapes, 100 of these shapes. It doesn't matter. A lot of variety of other functionality has been added here, but basically we're just showing the concept here. We're just going to take all 4 of these. We're going to pick existing ground. We're going to take the area, and then we're going to transform basically 1 foot down, and then we're going to encapsulate these meshes to create topsoil. As you can see, we have topsoil created in those zones, and you zoom in here, just basically paralleling it and forming a layer. Now that could be many other things. It could be hazardous. It could be used for design features. It doesn't really matter. But right then and there, we're able to report on it through our quantities by name boundary tool. In this case, we're just taking the whole model here. So we're looking at everything in this DGN, what we see, and we're reporting it to you at this time. Pretty simple. So let's take a little look at Open Tunnel. How many people do TBM work? Well, we have a little example here. They have some fun here. But I think it's going to point out a few things here. I just have a corridor. I have a TBM. Basically, they're solids and stuff. So I already took these solids and I converted these to mesh. I did a mesh combined and I referenced it to the corridor. Well, if that's the case, I could go target aliasing, right? Pick that structural concrete, apply it. My end conditions and stuff can simply hit that mesh. More importantly, let's take a little further look at this. In the perspective of the road going into TBM, isn't that already existing condition? It's a sequence in time. It's sequencing. I could basically fool the software here if I like and just say, hey, look at that. That structural concrete is my existing ground. Why not? I could choose any mesh to be existing also. So in this case, I'm going to go in here. Let's just run cut fill. I could fill in that material there and not even worry about anything else and just say, hey, I could call it whatever I like for the cut and fill, get a feature definition, and fill in that material there. Just for fun, you can see it's just going to look at the existing TBM, looks at the mesh, it's featureized, and basically fill in. So having a little fun with it, but I think the concept here is it could be more than what we always perceived. Think outside the box. Existing ground does not have to be a terrain. It could be a mesh. It could have overhangs. You could do other things, a rail platform. It doesn't matter. It's all based on your needs. So let's continue to think about this a little bit more with mesh. Well, if you could do that with open tunnels, microstation graphics. What about older Bentley projects you have on the shelf? You're pulling up those models. You just need to bring those meshes in and featureize them. I could bring IFCs, convert them in from the solids, convert them to mesh, and then do it. I could do it with the competitive software. It doesn't matter if I have a foul DWG X reference coming into my DGN. I could use that, harvest it, and work with it. I could do stuff with their other competitor software that they probably only could dream of with this stuff. It's quite nice. Take a look at something else we added to our next release, just coming out. So we enhanced the ability to make some closed meshes. In this case, you just don't have to use it for existing. It could be done for design. In this case, surface templates. We always are. I'll request to, hey, could I do overlay? But maybe it's construction. I want to get values and volumes for that. So in this case, I'm just going to pick element to element, and I'm going to basically build from the bottom subgrade with these meshes here. So in this case, it froze there a second. I'm going to pick the bottom mesh in cross section, which is nice because it's pretty hard to navigate that in a three-dimensional model. And it's going to say, hey, what side? I'm going to use the lowest side of that mesh because it knows it's closed when I selected it. And it's going to be, okay, what's going to be your bottom side? Well, it's going to be my existing ground, also picked up in cross section. I can reset when I'm done. I can have multiple bottom elements, and it'll pick the lowest one of the two. In this case, I'm keeping it nice and simple, just picking one. But now I'm going to look at, can I limit this? Well, in this case, I just want to put this overlay in the region where this blue box is, basically from where that mesh exists to that line where I'm hovering over right now. So I'm going to pick that, and I'm going to create that mesh with a particular feature definition. As you can see, it creates in the three-dimensional model, and then obviously once I update my dynamic section, there it is. Obviously it has a volume. So you start thinking of what you could do with that. It's pretty powerful. Now I could pick, like I said, multiple meshes and fill that all the way across the bottom of that mainline corridor, and pick the top wearing course and the saddlebags on the cross, and just fill the whole thing in if I wanted to. But in this case, I just showed that those single meshes, in this case for both top and bottom. So looking at this, you look at an entire model, it's hard to digest. Some people look at it, well, you just gave me 4.2 cubic million feet of something, yards. It's hard to digest that information intelligently. Looking at it, understanding the scale, is it the best decision, is very difficult. So basically we need to provide tools to help you digest your data. It really is the bottom line. And we have 4 out there that really will help looking at it and getting quantities from it. And obviously, you looked at the name boundaries there a little bit before. We're going to talk about the end areas, which it's still part of the equation. It's still the de facto out there. I understand that it's not in a black box. People could check things, and we have likes of the mass haul, which are quite helpful. So we're going to be looking at that for the next several minutes. So, but before we do, the old tools. You might remember Roadway Designer, about 2004 or 5 it came out, inroads way back when, and we have some of these older tools. Some of this came forward, they're helpful. Component quantities for one. It's looking at the XML fragments, it's based off more or less, you drop a template, here it is, it's EAV more or less, that's what it's doing. It doesn't take account of clipping. We put some warnings there letting you know. Same with the dynamic sections. It's looking at one object. It's not model centric. Everything that you saw me show so far today is looking at the model, derived from that model, and that's an important part. These are just working within that object on that old technology. So they're handy in certain cases. You're just starting out on a new corridor, you're doing an overlay project, component quantities, excellent. Dynamic sections, just to get a feel of what you're doing working on that one corridor. But it's not a model-centric approach where you get all your ingredients put together and to give you the exact cut fill that you're looking for. So just keep that in mind. So we have an example of the element component quantities, and I'm not sure if everybody's aware of this tool. And basically, I have everything in a federated model. I'm an empty DGN with all these corridors, and I just want this ramp, and I just want the more or less the surface template at the location, and get the pavement quantities just for this ramp. I can select them. I get the element component quantity dialog, and it's looking at the 3D model and giving me the exact values from the DGN three-dimensional model. Nice part is I could open up an XML report, and I could get it in a report where I could see it, and it also breaks it up for, hey, this is a surface template, this is the corridor, and I could punch that out and to get it in Excel and start generating those costs. Maybe and separate it. Hey, this is ramp C. I want just this information instead of looking at the whole colossal of design here, because it's just too massive for me to digest, especially for what my purpose is on this job. Obviously, one that you see demoed a lot with Bentley for a while is the quantities by name boundary. It's quite powerful. A couple things with this tool is obviously it breaks up the model, but yes, we know about the mesh. We saw about all its planar and slope areas, but what about points? People forget you could break up points and get counts per name boundary for points. Also could get the linear length. So keep that in mind. It basically allows you to cut in chunks. This is the one thing that we needed to add. You start looking at it, I need to get volumes by sheets. I need to get it, maybe break it down as a construction sequence or see if it's constructible. Maybe I'm just in a construction phase where I want to just build chunks based upon to establish truck queues for that day, where I'm going to get a couple long stick excavators out there and start digging out what I need to do for the ramp C, ramp D, etc. And really start setting up what I need to do. Really, it's any purpose. It's how you want to interpret the model that is designed and handed out to you. So it is a quite useful tool. So remember we ran that Earthwork earlier on before. Now, it's an empty file. I'm sitting here thinking, well, that's looking pretty good. But, oh, geez, I ran topsoil. I might have also had geotechnical data brought in, where I need to show my limestone and a rock and all that. But in this case, I'm just dealing with unsuitable, and I totally forgot about it. Well, I could go back in here and, oh, there is my topsoil I created from those infield spots. And I could see in here in the section, oh, I forgot it. Do I have to redesign all those corridors and deal with that and make overlay templates and deal with that? No, all within that cut fill tool. So quickly, I'm going to go back. And this is the beauty of it. You never get all the information out front. In this case, I have the unsuitable. Later on, I might have custom and substrata. In this case, I'm just doing unsuitable, like I said. I'm going to run this through. And now instead of my fill running to existing ground, I'm taking my existing ground and digging out a foot. I'm augmenting my existing to be something different. So in this case, well, shouldn't my fill reflect that? I have to fill in the hole. I can't build a road on air. So basically at that point, well, I look at it and now I can see rerunning that the second time, I'm picking up the fact that I stripped all that fill out of there. It could be also for existing pavement. A variety of settings on how to deal with that. It gets into some detail, but that gets really into the really nitty gritty here. But the capability is also there. So that looks really nice. We took that into account, and basically I didn't redesign or remodel anything within my templates. What about the name boundaries? Well, I could use the sheets. Well, maybe I have different purposes. Well, I could build it with the sheet generation tools because they create name boundaries. I could use MicroStation graphics. Maybe I could just put them in a selection set and say, hey, just go do them all. That would be kind of nice. I could just pick one, say, hey, use this plan. I'm going to just scale it down because it's not a sheet. I just needed to fit in the areas where these corridors are. And boom, it's going to run through each of those two alignments that I picked. And I basically have name boundaries there. I could draw shapes for the ramps. You can get in the level detail what you need in creating those shapes. But the beauty is it's customizable. In this case, I can't have something clipping the same place 3 times here with the structure. So I'm just going to do some wizardry. I'm just going to use the MicroStation flood command. Nobody uses that, right? So I'm going to just flood those two name boundaries real quick, get the shapes that I need, and I'm just going to blow the other 2 away. So, okay, I did, but I have some red boxes here that I got to deal with. I could simply add those to those groups that I created quickly it's not a lot of work. I'm just going to go in here and say, hey, from a shape, I'm going to make a selection set. 1, 2, it could be 30, 500. I do not care. And basically, I'm going to go in here and say, okay, pick that. I'm going to append to the existing group, SR97. And I'm going to say, hey, I want to, give it an appropriate name. And basically, I need to turn on the existing geometry here. I almost forgot, because I want some EC attributes for the stationing there. It helps us with reporting. You get additional information. Pick that, and it picks that, and it asks you, do you want to take the selection set? I'm going to accept that, and basically I added those 2 name boundaries to the that I just created after I deleted the first 2 for the SR97. So pretty quick. It's customizable. Microstation shapes, name boundary tools, it doesn't matter. So at that point, taking that, we can start breaking that model up and digest. And really that's the key here. We featurized everything. We told everything how it's supposed to look, level, color, weight, but with the additional properties they're putting on these meshes, even the linears, we know what it is. So I'm going to just start chopping up this model and run some reports. So in this case, I'm going to go to simply the civil analysis tools, create name boundary. I'm going to pick I-95 here, and I'm going to select that, and I'm going to run this through. So it's a decent sized model here. At this point, I'm letting this run completely 100% real time. It's going to kick off. It's going to sit here, look at all the data. It's going to partition it with all those name boundaries, and it's going to start saying, here, I'm going to thread this out to each of those name boundaries. Watch the speed it starts picking up now, because it's going to look and start threading each of those name boundaries out, and it's going to run those reports for it and stitch together your XML report. So it's pretty darn quick for this size model. Now it's going to publish that XML. You can see that you have the slope areas, the volumes separated by each of those name boundaries running through there. You also have the linear lengths. You could go to the very bottom here, and you can see all those name boundaries are there. You could switch over to a volume.xsl. It's broken down more or less like almost like end area volumes here based off those stations, just giving you the volumes and no lengths in that case. So your XSL could be customized to whatever your use case may be. So quite handy. You could break down and do the 97 next and have those reports broken down in any way you like. Obviously, they are in there. You copy, paste, move them to Excel, generate your costing appropriately with the appropriate costs that you have, and add your contingency in and get your cost estimate to your boss quickly. That's the name of the game here. So let's take this even another step. Think a part where a lot of people don't even know what it does. Display clipped graphics. I can't even say it. A lot of people don't know, why do you have that? Well, it makes a copy of the graphic and the limits of the name boundary, blah, blah, blah. What are you using it for? Well, if I'm sending this out to maybe IFC and I want to have it all separated, showing that information separated with certain item types put on it, I could publish it for a particular use case. This way it's cut up like it's going to maybe be constructed, maybe how it's going to be cost further downstream. So let's look at that a little bit. There's several tools that does this out there where we have the display clip graphics, but let's take a little bit of a more of a look at this. So basically we have the I-90, well, it's 97, state routes 97 here. And you can see that we have that in our reference bin. And the key here is an empty DGN. You're making a copy of the graphics. Well, if you're making a copy of graphics and splitting it, it's going to be confusing when you have the original corridor, the whole thing, with the other, and you run this tool. So you can see that we have the display on. Yes, it's going to run through. It's going to create you the same report. Nothing changes here. That's the beauty. But the thing is, it's going to show what has been clipped up and show you the results that it did in memory previously with clipping. And instead of just giving a black box, it actually shows you the results. It will clip the linears. It will actually also clip the mesh. So we're going to go in here in our 3D space, and we're going to just simply shut things down. So I'm going to shut off the original reference files and look in here, and you can see that once I hover over these items in here, shut the linears off first, make it a little easier to grab. You can see that the pavement is broken right where that name boundary is. the beauty of it is when it clips it, it reevaluates the slope area, planar area, and volume, because if you're going to send it like the IFC, you're going to have the correct properties being sent across. Also, too, it's going to be a validation when you're looking and checking CAD even. You go get the properties, and you can see the numbers as you clipped it up, and you could do that comparison. Just Q&A at that point. But it's quite handy because you know what has been quantified and how it's been broken apart in this case. So keep it in mind. It's a good little tool to know. All right. End area volume reports. You've seen me show all this new stuff, but there is a purpose for end area volume. Notice it's a report. The key to it is true EAV. However, model is king. We are slicing the 3D model. You don't need the trouble to actually make cross-section sheets. All you do need is know the name boundaries that you're using, because it dictates the interval for this analysis, because obviously end areas, area 1, area 2, average, distance, you know the story. So basically that is the key with that. It gives you a way to check. It's a Q&A tool. That's really what it is, but really it's based upon the same thing, the three-dimensional model. This also has been multi-threaded out, but here's a small, nice example. And this was kind of handy here before I started, because there's existing pavement, there's topsoil. As you can see, some of the existing pavement in here is broken up to different depths. So it was modeled more tediously. I guess I just was a little lazy, but with this, it's a very good data set, and I think you'll get the point here. So with this, I'm just going to let this go through and basically go to the end area volume report, and it's going to ask you what name boundary group do you want to use. There's only one in here, it's just called main. I'm going to select that, and it's going to interrogate the model the same way as the quantities by name boundary. It needs to know what existing is. It needs to know the proposed. It's going to look at the volumes of that. It's going to, what is a part of the mass ordinate? What is tagged true for the mass ordinate? And it's going to start pulling those in and help you build that cut fill report here. Also, too, if you navigate to a different XSL file, you can see that it's going to break that down to more detail, where you get the topsoil removed, the milling removed and replaced, and all the other values, and obviously total that on the bottom. So it's quite helpful because it's based off the area, because that's a physical way where an individual could check this prismoidal approach that we seen earlier with the fact that it's what's on the cross sections. So as you can see, we go to our asphalt milling on the bottom. You can see the removed, and then removed and replaced. And these are all set within the volume options settings for unsuitable. All right. I think we're going to be good on time. Lastly is mass haul. Moving dirt once is paramount. We talked about the price of fuel, the cost of the project. You basically move dirt once, move it the correct direction, and go with that. Now, it's simply, in the past, we did cross sections, and you try to limit the cross sections, navigate them to figure out your mass haul. It was difficult. It really was. If you have a three-dimensional model, and you started looking at something a little bit more particular, like I have a northbound, southbound I-95. I'm looking at it, and when I'm constructing this, I only can move northbound 95's dirt at one time. I can't move southbound because I got to move traffic somewhere to do this project. So I'm going to move everything northbound to the southbound lanes, put them in the cattle chutes, and I'm going to, all my earthwork, I'm going to move on to the northbound side, in this case, the right side of this model. So I'm going to kick this off here, and I'm just going to go to the mass haul diagram, appropriately the dump truck. And I got a couple methods I could choose. I could do an interval, because I'm looking at this as a construction point of view. I don't have name boundaries. I don't really even care about name boundaries. I want to know which way to move dirt. I'm going to look at the alignment. In this case, it's going to be the center line of I-95. It's going to, once I pick that up, it's going to determine the limits of that. And you can see I'm going to start looking at the parameters on how frequently I'm going to do the analysis, every 50. I'm going to look 10 feet to the left, just in the middle of the median, the side I can move the dirt, and we're going to look to the right side, to the northbound lanes, 150 feet. That's the only area I'm looking at the cut fill, and I'm clipping the three-dimensional model to determine how much cut fill I have in each of those sections, so I could figure out in that range to plot that under the curve for the mass haul diagram. And that's what we're doing with that. So we're looking at, again, the 3D model to do this. So it's going to plot that in the XML report for the mass haul. You can see the mass ordinate being placed there, and you can see the mass ordinate being plotted on that more or less a profile space, showing you the balance points and which way you should move dirt. Obviously, this is mostly cut here because we're mostly moving pavement out. It's not like we're adding additional lanes in this region, but still, it gives you an idea which way the dirt has to move. And as the construction sequence continues, I could look at the southbound the same way I just did it in the northbound situation. So with that, I think we're on time, close to the 45 minutes. There's a lot to the meshes and earthwork that we've done in ORD. I hope you open your mind to look at it in a different way. It's just mesh. Yes, it is just mesh, but basically it's the foundations to open roads.